This is a public meeting presentation for the Rockwell International Wheel and Trim site. My name is Shelby Johnston, and I'm the RPM, or Remedial Project Manager for the site. Today I'm going to share with you the Engineering Evaluation and Cost Analysis, also known as the ECA, that was developed to evaluate early actions to address groundwater contamination at the facility property and areas beyond the facility property. The purpose of community engagement is to facilitate community involvement in the Superfund process and have two-way communication between the public and EPA. The public comment period on this action will be from Monday, October 4th through Friday, November 3rd of 2021. Please use the contact information listed here and on the fact sheet to submit your comments or questions to EPA. When the comment period is closed, EPA will respond to comments in a responsiveness summary that will be added to the administrative record. The ECA administrative record is the collection of key documents used by EPA in selecting the recommended ECA remedy. The full AR is available at the site's webpage listed here, and the Elizabeth Jones Library has a few copies of the ECA and computers available to access the full AR at the site's webpage. Superfund sites are discovered when the presence of hazardous waste is made known to EPA. Once a site is identified, all existing information is reviewed, and the site is inspected to determine its history and effects on people and the environment. Information collected during the assessment phase is used to score the site for potential addition to the National Priorities List, or NPL, according to the threats to human health and the environment. Remedial authority starts when a site has been proposed to the NPL. Removal authority starts when EPA has determined that a removal action can be taken to reduce acute risk or prevent further spread of contamination. For example, the removal action taken at the facility was to immediately reduce the risk to workers from the indoor air contamination by the vapor intrusion pathway. Removal actions can take place at any point in the Superfund process, but steps are taken to ensure that any removal actions are consistent with the future site actions. This is a comparison of the process for remedial actions and non-time critical removal actions. Non-time critical removal actions are conducted at Superfund sites when the lead agency determines, based on the site evaluation, that a removal action is appropriate and a planning period of at least 6 months is available before on-site activities must begin. Most non-time critical removal actions are carried out by EPA, but in this case the action is being carried out by a willing, potentially responsible party, or PRP, with EPA oversight. The non-time critical process is like the remedial process, but typically there is already enough data to use as a basis for determining if a removal action is warranted. Once the removal action determination has been made, the engineering evaluation and cost analysis, also known as an ECA, can be compiled using the data to evaluate potential actions. As you can see here, both processes have an assessment stage, but the remedial process includes an additional sampling component for the site to be evaluated for NPL listing. The characterization stage for the remedial investigation, or RI, also requires extensive sampling and evaluation so that a full human health baseline risk assessment and ecological risk assessment can be developed. The ECA report is similar to the RI, but the purpose is to have a well-defined area of the site selected for removal action to complement the future full site remediation. In April 2019, EPA and Meritor signed a voluntary legal agreement for Meritor to perform a non-time critical removal action. Using the ECA, options were evaluated to reduce the spread of contaminated groundwater at and beyond the facility. The contaminated groundwater generally flows towards Riverdale Creek, and as it flows, it slowly spreads. The size of the groundwater contaminated area, or plume, can grow if the source of contamination is not addressed. Once the source is cleaned up, the plume will naturally break down and shrink over time. A pilot test system was installed to pump and treat the contaminated groundwater as part of this investigation. The results from this operation were included in the ECO report to assist with evaluating the cleanup options. The Rockwell International Wheel and Trim Superfund site includes the Grenada Stamping Facility, the Eastern Heights neighborhood, Riverdale Creek, the rail yard, which includes the stone yard, and the Moose Lodge Road area. This action is focused on groundwater at the facility and just outside the facility. Several companies with wheel cover manufacturing operations have been located at the facility from 1965 to 2004. The chemicals trichloroethene, also known as TCE, toluene, and hexavalent chromium were used in production of the wheel coverings. Use of TCE and other regulated hazardous chemicals at the facility ended in 1992. The facility buildings are currently in use by ICE Industries for metal stamping operations. The facility property is bounded on the north and on the east by railroad lines, on the south by vacant land, and on the west by Riverdale Creek. The Eastern Heights neighborhood is north of the railroad line, and the Moose Lodge Road area is east of the railroad line. The city of Grenada is located approximately 1 mile to the south. The Resource Conservation and Recovery Act, also known as RCRA, is the federal law that governs hazardous waste at operating facilities. The facility held a permit under the Mississippi Department of Environmental Quality, also known as MDEQ, RCRA program from 1990 to 1995. MDEQ directed the facility owners to address soil and groundwater contamination from an on-site landfill beginning in 1990. Between 1991 and 1993, at the direction of MDEQ, the facility owners began investigating areas where contaminants may have been released, also known as source areas. Under the state's voluntary cleanup program, Meritor also began cleanup of the former disposal area located in the Moose Lodge Road area. In 1995, oversight of the cleanup at the facility transitioned from MDEQ to the EPA under a RCRA corrective action permit, since that part of the program is not delegated to the state. MDEQ has retained cleanup oversight of the Moose Lodge Road area under the voluntary agreement and over the RCRA post-closure of the Equalization Lagoon. Shown here are additional actions that were taken under EPA RCRA. In December 2017, oversight of the site was transitioned to Superfund due to the complicated land ownership issues and a preference to view all areas together to better coordinate the cleanup strategy. To prevent a loss of work already underway, EPA Superfund has elected to have EPA RCRA continue to oversee work on the PRB and for MDEQ to continue oversight of the two previously mentioned actions until a site-wide agreement has been reached with the PRPs. The facility properties have restrictive covenants in place to prevent the use of groundwater until the contamination is cleaned up. Superfund is a risk-driven program. If there's an unacceptable risk, cleanup is warranted at a site. The study area was found to have concentrations that exceeded health-based risk levels, also known as MCLs, of trichloroethene, cis-1,2-dichloroethene, vinyl chloride in all locations with impacted groundwater, and hexavalent chromium and toluene in a few discrete areas at the facility. There is no current unacceptable risk to groundwater because the groundwater is not currently being used. There is no current completed pathway for vapor intrusion, also known as VI, since the facility has a subslab depressurization system, thus no unacceptable risk for VI. Future risk is evaluated to determine if there would be a potential for unacceptable risk if no action were taken. Because this has many assumptions, it could also be described as hypothetical. All groundwater is considered a potential future drinking water source by EPA and MDEQ, so there is an unacceptable risk for the potential future groundwater use since MCL is exceeded. Because the vapor intrusion pathway is based on its spread from groundwater, there is also the future potential risk for vapor intrusion pathway to be completed if action is not taken. The ECA objectives were broken into two areas for grading of the action alternatives. The primary objective is to minimize the migration of contaminated groundwater at the operating facility, which is where the highest concentrations of contamination were found. This includes the facility building where the current subslab depressurization system is located. The groundwater hydraulic conductivity, or slope, in the area is reasonably flat. We wanted to evaluate the groundwater flow and contaminant concentrations and measure the change when a pump was applied. The pilot well study, Extraction Well 1, results combined with groundwater modeling show that expanding the system could capture all areas of known groundwater impacted within the study area. The treatment system can consistently remove VOCs, for example TCE, present in the groundwater to non-detectable levels and those present in the air to levels well below discharge limits so that there would be no additional impacts to the air quality. The one well pilot extraction and treatment system removed more than 17,000 pounds of TCE, more than 1,400 gallons within its year of operation. From August 2019 to August 2020, the PRP constructed the pilot well and the system to be used to pump from the well and treat any contaminants that might be recovered. This slide shows the constructed pump and treatment building, interior piping, treatment system, and the related components. As a risk-based program, it is the goal of EPA to achieve overall protection of human health and the environment. The ECA evaluation criteria are used to weigh the potential treatment actions for the site. The following criteria are independently scored, and then the best alternatives are compared. Balancing criteria looks at the short and long-term effectiveness and permanence of treatment. The treatment must reduce toxicity, movement of contaminants, and the amount of contamination while being cost-effective. Modifying criteria allows for review by the state and the community to raise comments for consideration in choosing a final treatment alternative. The technology screening summary shows each potential action graded against the evaluation criteria. On the left are the criteria, and on the top are the different technologies evaluated. These are scored from most favorable in green down to least favorable in red. From the screening, the in situ chemical oxidation, or ISCO, enhanced reductive dechlorination, ERD, and pump and treat were carried forward for full comparative analysis along with the no action alternative against the evaluation criteria. The three potential alternatives were compared to the no action alternative as a baseline if no action were taken. These are scored from most favorable in green down to least favorable in red. The no action alternative does nothing to address the contamination and would likely fail to achieve EPA, state, or public acceptance. The ISCO alternative would reduce unacceptable risk. However, implementation would be very difficult and inefficient, and it would impair the aquifer's current ability to remove hexavalent chromium from the groundwater because it will change the pH. The ERD alternative would reduce unacceptable risk. However, implementation would also be very difficult. This alternative would also release arsenic to the groundwater because it will change the groundwater chemistry. The pump and treat alternative would reduce unacceptable risk. Implementation is also more favorable for the pump and treat, given that all contaminants can be addressed together with one action, and the system would give a much larger area of impact with less disruption to local businesses and the community. The pump and treat was selected as the recommended alternative for its ability to be effective for all contaminants without changes to the groundwater chemistry, and the ability of the system to address larger areas of impacted groundwater with less disruption to local businesses and the community. For comparison, this is a figure showing the groundwater flow when EW1 is not pumping. The circle with 173 indicates a high point in the groundwater flow where there is a split and groundwater will flow perpendicular to these blue lines from the approximate center of the circle. Most of the flow in this aquifer flows towards Riverdale Creek in a general east to west movement. The green line in this figure shows the approximate groundwater areas currently impacted by contaminants. This figure was created using the data collected from EW1 and by modeling the anticipated pattern of groundwater flow, also known as radius of influence, for proposed wells EW2 and EW3. The gallons per minute, GPM, shown on the two proposed wells are estimated pumping rates to achieve the shown effects. The pump can be adjusted to ensure that the well achieves the desired groundwater flow. After the comment period, EPA will address comments in the responsiveness summary and finalize the ECA. An action memorandum will be drafted stating the selected remedy. Once negotiations for the remedy are completed, including a schedule, the removal action will be planned to initiate in late winter or early spring of 2022, pending weather conditions and materials. This concludes the presentation for the Rockwell International Wheel and Trim ECA. Thank you so much for joining me to learn more about this action and share your questions.